The Earth takes a year, 365 days to travel its orbit, and its average distance from the Sun is 150 million kilometers, which is the measure unit of distances in the solar system known as the astronomical unit, and abbreviated AU. An alternative way to define the astronomical unit passes through the light time. In particular, we can say the average distance Earth-Sun is equal to about 8 light minutes. This means that sunlight takes 8 minutes to arrive on Earth, so that the sunlight we see at a certain moment is not that of that moment, but it is the sunlight which left from the Sun 8 minutes earlier. In other words, if the Sun went out, for example, at 2:30 p.m., we would only notice it at 2:38 p.m.
This is a template of the basic angelic design. In an ethereal-based form, the angelic order of dominions for each world will be comprised of a certain mixture of conjured particle elements. These particle elements will be the main source of that which makes life possible on each planet. The angels' duties will be to only maintain the proper balance and fusion of elements necessary for life to develop. They will in no way create or influence the life on those worlds in their development. They shall sustain themselves with the mana pools or resonance field of each planet's atmosphere.
Distance of 2 to 3 AU from the Sun, between the orbits of Mars and Jupiter, we would meet the asteroid's main belt. Asteroids are those small rocky bodies, whose dimensions span from a few kilometers to a few hundred kilometers. They are so small that they aren't visible through unaided eye, but only through telescopes. We could reach asteroids in a few years with a traditional spaceship or probe. Let's move on. We would need around 10 years and 40 AU to fly by Pluto, one of the outermost bodies of the solar system. Try to imagine it in your mind. If you were on Pluto's surface and had to look at our planet, you would only see a pale blue dot. That is the same sight captured in 1990 by Voyager 1 NASA probe, while it was leaving Neptune behind. Around Earth, only the dark vastness of the universe, barely illuminated by starlight. Now we have left behind our solar system, and we are going to enter the interstellar space. To get to Proxima Centauri, the closest star to Earth, we have to cover a bit more than 4 light years. We remember a light year is the distance covered by light in a year in the vacuum and is equal to about 10,000 billion kilometers. The Milky Way is our galaxy. It is an immense group of stars held together by the force of gravity. It has the shape of a flattened disk with a bright core in the center, where the star density is very high, and spiral arms around it. Around the core there is a spheroidal halo, which extends outside the galactic planet. At this point, it could be useful to introduce the parsec, equivalent to 3.26 light years, to measure the dimensions of our galaxy. So our Milky Way has a diameter of around 30,000 parsec, which are equivalent to 100,000 light years. So if we were back on the Millennium Falcon again and had to cross the Milky Way from one side to the other, traveling at the speed of light, the fastest thing there is, it would still take us 100,000 years to cross it all. Or same analogy seen before, with the Sun represented as a 14-centimeter diameter sphere, our Milky Way would have a dimension of 100 million kilometers. That is equivalent to make 2,497 turns of the Earth along the equator. The galactic halo has a diameter of the order of 30 kiloparsec and is populated by old stars that are stars with an age double that of the Sun. In the spiral arms, instead, there are younger stars, like the Sun, located within the arm of Orion, a secondary arm of the Milky Way between the arms of Perseus and Sagittarius. Our star, the Sun, is only one of the estimated 200 billion stars in the galaxy. Galaxy with capital initial letter because it is the galaxy par excellence. Our galaxy, in fact, its name derives from the Greek galaxias.
The excess discharge from the atmospheric fluctuation will sustain their existence where that discharge breaches the surface at crossing intersecting lines of the resonance field as it comes through the mantle of the planet and begins its transition into the atmosphere to shield the surface from cosmic radiation. Any planet that has life upon it all share this one quality, a shield that blocks radiation from space from cooking any forms of life that may dwell upon them no matter what form they may come in. They shall remain in an astral type stasis known as ethereal forms, which is a spiritual embodiment used in various religions and practices, such as spiritual gateway guardians, watchtower guardians, higher plane entity projections, wrathful spirits, unbound spirits, and many others. In this state they will be capable of traversing the luminescence field and thus travel large distances easier. It seems the key to traversing between the astral, spiritual and mortal planes lies within the aspect of emotion. It is said within the texts on eons that to transcend from an intangible state of thought to a tangible state within pleroma or the mortal plane occurs when the eon commits an act of sin or emotional-based action. This record is from an astral-based perspective that transcends from the ethereal astral realm and begins the final phase of reincarnation into the mortal realm. From this point one sees the tunnel as the soul redshifts from the third-dimensional plane of the astral realm to the fourth-dimensional plane, which is the current region we exist within, that is the solid particle field of the universe, for now.
Distance from the galactic center is about 8,000 parsec, or if you prefer, 26,000 light years. Our star takes around 250 million years to go along its orbit around the galactic center. This means that since its formation, it's only made around 25 orbits around the center of our Milky Way, traveling at 215 kilometers per second. And it is good that the Sun is not in the center of the galaxy, because in it there is a supermassive black hole, Sagittarius A star, a monster with a mass equal to about 4.3 million times the solar mass, and an immense gravitational field such that even light is not able to escape. This huge black hole is located in the direction of the constellation of Sagittarius, a constellation observable in the summer for the inhabitants of the northern hemisphere and in the winter for those in the southern hemisphere. Since a black hole does not emit light in the visible band, the same we see with our eyes, it is not visible directly through a telescope, but can be detected through indirect methods. Number 1, radiation emitted by the accretion disk around the black hole. A black hole is surrounded by an accretion disk made of matter that orbits spiraling around it. This matter sooner or later falls into the black hole. Before ending up in it, however, it is heated to very high temperatures of the order of 1,000,000 degrees, producing electromagnetic waves of very high energy, such as X-rays and gamma rays. Number 2, study of the orbits of the stars closest to the black hole. Studying the movement of the stars in the area of the galactic center, it was noted that they seemed to rotate around nothing, because apparently there was no visible celestial body in that area. Studies conducted by research groups led by astrophysicist Andrea Ghez and Reinhard Genzel, who won the 2020 Nobel Prize in Physics together with Roger Penrose, over the course of many years, have shown the existence of a celestial compact body at the center of our galaxy, right in the area where the black hole Sagittarius A star is located. And what about the Milky Way? Is it at the center of the universe? Even in this case, the answer is negative. The Milky Way belongs to the local group of galaxies, with a dimension of 10 million light years, or 3.1 MPC megaparsec. We remember that 1 MPC is equal to 1 million PC, and that 1 PC equals to 3.26 light years. The local group includes more than 70 galaxies, most of them of small size. The center of mass
Once the time span of this universe we know passes, then we too shall become the atomized dust of the new particle field that will emerge from the singularity as the universe ascends to a fifth-dimensional field perspective of solid matter particles, which I cannot exactly describe in any form people would understand, because it's a 5D perspective and we are 4D objects, and thus our logic is 4D based and incapable of comprehending such methods of logic. I can theorize this, however, that the luminescence field that is the tangible gateway between our dimension and the spiritual realm may be the fifth dimension and redshifting, or increasing your speed of travel beyond the speed of light as galaxies do when they've traveled at a distance and speed to where no matter if we traveled at the speed of light we would never reach that galaxy because it is beyond the observable universe's limits. When that occurs, the galaxy will shift color spectrums and become red in appearance.
So we know our planet, Earth, 70% water, comfortable temperature, great music and culture. 10 out of 10 would visit again, but where exactly is the Earth? The Earth is here in the inner solar system orbiting a star called very imaginatively by humans, the Sun, or Sol to give it its Latin better name. The Sun is a rather mediocre but stable main sequence star that is about halfway through its life cycle. In about 4 billion years it will swell and completely obliterate all traces of our long-dead civilization, but we haven't gotten to that bit yet. It is currently powered by fusion of hydrogen into helium and energy and weighs 9.8 nonillion kilograms, which is such a massive number that our primitive simian brains can't even visualize that massive amount, especially the ones that still use imperial. The Earth orbits 149 million kilometers, or 1 astronomical unit, away in the inner solar system, while Jupiter is 5 times further out, Neptune is at 30 AU, and the edge of the solar system and Voyager are between 80 and 100,000 AU away, which is very specific. But where's the solar system? Right, here's where it gets interesting and I can start filling this video with more facts and less spite. Our nearest stars are Proxima, guess what that's called in Latin, and Alpha Centauri, which are 4.4 light years away, as well as Barnard Star, Wolf 359, and quite a lot of others. It's quite hard to visualize our position in 3D space, but I'm going to try my best, or will try my best, as I haven't edited this video yet. This is made especially hard as all of these surrounding stars are travelling in random different directions compared to us. Our local neighbourhood of stars is inside an interstellar gas cloud called the Local Cloud. In fact, the Sun will enter a separate cloud called the G Cloud in the next 20 millennia or so. Both of these clouds are flowing out from a dense area of star-forming gas called the Scorpius-Centaurus Association, which sounds like an accounting business, but for our human purposes we can just ignore most movement as it really won't matter on the timescales we're talking. In the cloud there aren't as many stars as elsewhere in the galaxy, but the whole thing is 1.5 million astronomical units, or 30 light years across, which is pretty small compared to what's to come. Zoom out further and we see our local interstellar cloud is pretty much exactly halfway down the Orion arm of the Milky Way, which is about 10,000 light years long, but despite this figure it is only a very minor arm as it offshoots from the massively large Perseus arm, which is about 3.5 times larger. Yeah, and this leads us to the Milky Way. You may have heard of it. It's our galaxy, and for once it's kind of big compared to its neighbours, but not the biggest. We'll get to that later. It's a barred spiral galaxy, called that because of the bar shape in the centre, and is over 150,000 light years across, around 2,000 light years thick with a bulge in the middle, weighs an amazing 0.5 tredecillion kilograms, which is over 400 billion times what the Sun weighs. Yeah, it's not like we can step back and look at it from the side, because not only will it take 1 million years for even light to get that far, but there is no side in space, it's all relative. So how do we know what it would look like? Well, we can calculate how far away they are due to how far they appear to have moved in a 6-month span. In reality, we're the ones that have moved, but judging from how far that star has moved relative to distant galaxies, called its parallax, we can determine through simple geometry how far away they are. Also, we see other galaxies from the side or top or whatever, and work out generally how galaxies are structured. We can't see most of the stars on the other side of the core due to the intense light and mass there, but applying our general rules of galaxies to the distant stars we can see, we get a map something like this. Hooray! Usually in films also you hear about the alpha quadrant of a galaxy, but quadrants are a thing for real galaxies as well, except they're numbered and technically we're in 2? Yeah, because the 0-degree line, the equivalent of the Greenwich meridian for the galaxy, is always drawn so that it intersects with the sun, which is a very self-centered thing to do, but we don't exactly have much else to base it off of. But like our sun, the Milky Way has its own local cluster of galaxies, and that's what it's called, the local cluster. Most are tiny compared to ours, and some even orbit the Milky Way like planets to a star. The Milky Way is one of the biggest in the local cluster, and second only to the Andromeda Galaxy. It is a widely known fact that these two galaxies are destined to collide, and the black holes at the centre of each will merge and form the initially chaotic Milkdromeda Galaxy.
If we lay a grid over the galaxy, we can locate some of the stars, nebula, and H2 regions we have seen in this chapter. Actually, all the local neighborhood stars would fit into the red circle I used to locate our solar system. That would be stars like Wolf 359, Altair, Vega, Polaris, Capella, Aldebaran, the Pleiades, and Betelgeuse. They are all with us in the Orion Spur, as is the Orion, Horsehead, Cone, Witch's Head, Veil, and many other nebula. In Sagittarius, we see the Jewel Box star cluster, and the Trifid, Omega, Lagoon, Eagle, and Cat's Paw nebulas, among others. In Perseus, we see the Rosetta, Heart and Soul nebulas, as well as the Crab supernova, to name just a few. In fact, except for the hypervelocity stars and a few of the supernova remnants, everything we have seen in this chapter is within this red circle. As vast an area as we have covered, it is only a fraction of the Milky Way galaxy.